Hello, welcome to the second PowerPoint presentation here in module number 6 for the course Environmental Economics and Markets, and my name is Steve Latender. In this brief presentation, I will provide you the background to complete the fourth and final quantitative Excel assignment. In this assignment, students will calculate marginal values based on total values. We will also use probability theory to calculate expected values. So let's go ahead and get started. So we now know that the efficient level of pollution is the point where marginal benefits are equal to marginal costs. In this assignment, students are given total abatement costs and total damage costs avoided. The total abatement cost represents the cost of reducing pollution in the environment. The total damage costs avoided represents the benefits. As you reduce pollution in the environment, you avoid damages, and those damages economists understand as being benefits. So here we have an example. We've got a total abatement costs and total damage costs avoided. The current level of pollution in the environment in this example is 2,000 parts per million. At that point, the status quo, the cost to clean up the pollution are 0, and the benefits of avoided damages are 0 as well. Now, as we begin to reduce pollution levels from 2,000 parts per million down to 1,000 parts per million, we have to spend money to achieve that outcome. So total abatement costs go from 0 up to $500,000. And to calculate the marginal abatement cost, the cost to take that step from 2,000 down to 1,000 parts per million, we simply subtract 0 from $500 to arrive at marginal abatement costs of $500. Now, we say we want to reduce pollution levels from 1,000 parts per million down to 500 parts per million. In this case, we subtract $500 from $1,500 to get marginal abatement costs of $1,000. Similarly, if we look at total damages avoided, or the benefits of pollution control, we can calculate the marginal benefits, or the marginal total damage costs avoided. So again, in the first example, the current level of pollution is 2,000 parts per million, so there are no benefits given this current status quo. However, as we reduce pollution from 2,000 parts per million down to 1,000 parts per million, we see that total damages avoided are 1,000, and we can calculate the marginal damage cost avoided by subtracting 0 from $1,000 to get marginal damage costs avoided of $1,000. So now, again, assuming we want to reduce pollution levels from 1,000 parts per million down to 500 parts per million, here the marginal damage costs avoided would be $1,000 minus the $1,800 for a marginal damage cost avoided of $800. So this simple mathematical example shows us how we can derive marginal values from total values, and students will do this as part of this assignment. The next part of the Excel assignment requires students to calculate expected payouts or expected values. And this is based on using probability theory. And probability is used to assign probabilities to various outcomes, and we can determine what the expected outcome would be by multiplying the probability of a particular outcome times that outcome. As a simple example, we know that when we flip a coin, there's a 50% chance that that coin will be heads, and a 50% chance that that coin will be tails. Now, this is a different application of probability theory, where we're actually assigning probabilities to particular payments, in this case, fines. So we can determine what the expected payout of the fine will be by multiplying the probabilities for each of the various fines times each of those various fines and summing those up to get our expected payout. And that's what this equation here shows. As an example, we can think of a lottery ticket. This is a $5 New York State lottery called Monopoly Jackpot. It's a scratch-off ticket. And on the back of these lottery tickets, they list the chances. And those chances, of course, can be converted into probabilities. Simply divide 1 by the chance, in this case, the chance of winning a $5 from a scratch-off ticket, be 1 in 13.33. We simply divide 1 into 13.33 to get the probability. So then we would multiply each of those probabilities times each of the particular prizes and sum those up to get our expected value. So when you go through that exercise in this particular example, you would see that the expected value or payout from this lottery ticket would be $3.39. And again, this is for a $5 scratch-off ticket. So the lesson here is that the house always wins. They establish the chances of winning the various prizes in such a way that at the end they will always end up making more from the sale of a lottery ticket than they have to actually pay out for the various prizes. So again, in this example for this assignment, you will take this probability theory and apply it towards to various fines that a firm might receive from a visit by the EPA, and then you sum across those probabilities times the outcome to determine what your expected payout would be for the firm. So with that, you should be all set to complete the Excel assignment here in module number 6. And if you have any questions, please feel free to email me or give me a call. Thank you so much for listening.